you need something that multiplies for negative 20 times 1 is a negative 20, but adds for a negative 1. Hopefully you're thinking of negative 5 and 4. When I multiply, I get a negative 20. When I add, I get a negative 1. Perfect. The 5 doesn't do anything. You can just ignore it. X minus 5 equals 0. You add the 5 over, you get a 5. If you plug it in, you get no negatives, so it's a keeper. Here, when I subtract over the 4, I get a negative 4, and it gives me a negative log here and a negative log there. So that one's extraneous. I can't count it. Again, pause the video, try this one on your own, and then come back, see if you got it right. If you did, you can move on. If not, then, watch the steps. You should start with your base. To the power of 5 is equal to x minus 6. 2 to the 5th is 32. And then just add the 6 over. Then you get 38. One wasn't bad at all, actually. Okay. Just some more practice examples. I'm assuming this would probably be, like a day 2 of notes or something of the sort. First, it looks like I can rewrite this. So this 2 can become a power, so that would be log of x squared. Over here, since I'm adding 2 logs that have the same base, instead of addition, I can multiply them together. So it would be log of the quantity x minus 1 times quantity x plus 3. Since they both have a log base 10, that portion is already equivalent. So you basically just ignore it and work the other pieces, other parts. So I have x squared is equal to the quantity x minus 1 times quantity x plus 3. I'm going to go ahead and distribute that. X times x is x squared. X times 3 is 3x. Negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. Combine those middle terms. I get 3x minus 1x, which is 2x, minus 3. All right, I see I have an x squared on the left and an x squared on the right. So if I go and subtract this x squared over, cancel, cancel, I get 0 is equal to 2x minus 3. Add the 3 over. And since I'm trying to get x by itself, I would divide by 2. So it looks like x is equal to 3/2. And if you would plug 3/2, which is a 1.5, into all of these, you would get all positive logs. So that's a good sign. Again, probably a good time to pause. Try this one on your own. See how it works out for you. But you have log base 4 of 3x. I can combine these. Since it's subtraction, I can write it as division. So log base 4 of x plus 2 divided by x. Since they both have a log base 4, I can ignore that part because it already matches and just work with the 3x is equal to x plus 2 over x. Since I'm dividing by x, I'm going to take this x and multiply it over. So multiply. 3x times x is 3x squared. I see I have an x squared and an x. As soon as I see I have more than one type of x, I want to get everything on one side, set it equal to 0 and factor. While I'm doing that, I always want to make sure my highest power, this term here, is positive. So I'm actually going to move the x and the positive 2 to the left side. So I'm going to subtract the x, subtract the 2. So it looks like I have 3x squared minus x minus 2 equals 0. Since I have a leading coefficient and I can't take a number out this time, I'm going to have to do my cheater step. So since that's a 3x squared, I'm going to do a little baby 3x above the parentheses. Everything else is exactly the same. Still do a rainbow. I need something that multiplies from 3 times negative 2 is negative 6, adds for negative 1. That would be negative 3 and 2. Negative 3 times 2 is a negative 6. When I add, I get a negative 1. So you have negative 3, positive 2. With the cheater step, you take out the highest number you can, and that number is garbage. It never belonged to begin with. That's why it's called a cheater step. So for instance, here I can take out a 3. That 3 is trash. It just disappears. Here I can't take out anything. So whatever drops down, that's the good copy. And you always want to quick check your good copy. So x times 3x is my 3x squared. Negative 1 times 2 is negative 2. Awesome. It's called a quick check because it doesn't count, it doesn't check that middle term, but usually if it works for the 3x squared and the negative 2, you're good for the middle term too. Now that I have a quantity times a quantity is equal to 0, you set both equal to 0 and solve. Add the 1 over, you get a 1. If I look, it doesn't make anything negative, it's a keeper. Subtract the 2 over, divide by 3. As soon as I see a negative, I'm weary, and right here, it would make a log base 4 of a negative, so that one's extraneous, we can't count it. So always make sure you check for that solution that makes your log negative. It doesn't work. I've had people stare at this one for a very long time, and as soon as I say, hey, what's your base? They're like, oh, and they get it. Base of 10, so if I start with my base of 10 to the power of 3 is equal to x, 10 cubed is 1,000. That's it, you're done. So your base is your friend. Your base will help you. For this one, if this is a base of 2, I'll never be able to write that as a base of 2, so I'm going to use a log. So it would be log base 2 of, you can't write those side by side, so it would be of 5 is equal to x squared minus 1. If I'm trying to get x by itself, I can add the 1 over. And then I could take the square root to get rid of the squared. Normally, when we do the square root, it's a plus minus. But we'll have to double check to make sure it works. So here's the weird part. Well, let me write this first. To type this into your calculator, we can ignore the plus minus for right now. But it would be a square root. Log base 2 of 5 would be log 5, you don't want to put this in parentheses, divided by log 2. Close the parenthesis, and then that plus 1. Now, when I type this in, let me grab my calculator quick. Hopefully you're also typing this in while you're waiting for me. So let's see. Big old square root in parentheses log 5. So I have to close that around that parentheses, just closing my log 5, divided by log 2. That's just closing the 2. This parenthesis is closing the whole log 5 divided by log 2, and then a plus 1. See how it's all still under the square root though? And I get about 1.823. Now, I want to see if I should also include a negative 1.823. So if this is what it should be, you can kind of copy and paste this answer. It would be 2. If you hit second negative sign, well, you'd have to do your power first, but if you hit second negative sign, it will copy that answer. But I wanted the negative version, so I'm going to put a negative first, and then I want to square it. You should already kind of have your answer. Minus the 1. That didn't work out. So let's see, did I type it in incorrectly? I think I did because I didn't put parentheses around my answer sign. So let's see how big of a difference that makes. It would be parenthesis negative. Oh, that's going to do the 0.5 now. Darn it. I'm just going to use a rounded answer. So if I did a negative 1.823, hopefully you already kind of know what I'm getting at since I feel like I'm wasting your time. If not, then keep following along. So the reason why I got 0.05 before was because I didn't put parentheses around the part that I squared. That was my problem. So I just kind of used this value, and you can see it's 5.00, and this is just because I used a rounded answer. But do you see how the negative value works? But honestly, you shouldn't have even had to check it, because since we're squaring it, the negative's irrelevant. So yes, it is both a positive and a negative. Long story short, all of that just to show you. It's both a positive and negative. The negative works mostly because when I square it, it goes away. So you don't have to worry about it not being in the domain or anything weird like that. Plus, it's not even a log. So don't forget, whenever you have a squared and you take the square root, check both the plus and the minus, positive and negative for your answer. This one here, since this is log base 3, I'm going to use that base of 3. Don't write these side by side, so it'd be to a power of 2. So 3 squared is equal to the x plus 1 over x. 3 squared is 9. I'm going to multiply this x over. And then all of a sudden, this is a pretty easy problem. If you look at this, if you have no idea what logs are, you'd be like, I'll never be able to solve this. But knowing that it basically just boils down to this, where you subtract an x over, and you get 8x equals 1, so x is equal to 1/8. That's not bad at all. You just have to know your properties of logs and how to rewrite all that stuff. I think we have one page left. Again, you know, pause the video, try these on your own, check them. If you get them right, awesome. If not, then watch the video, see where you messed up. For this one here, I notice, well, first I noticed that I can do x times 3. So I would do 2 to the power of 3x times 2 to the power of 2 minus x is equal to 3. Then I notice that since these have the same base, I can add these two together. So it'd be 2 to the power of 3x plus 2 minus x is equal to 3. 2 to the power of 3x minus x is just 2x, so 2x plus 2 is equal to 3. So I had to simplify all that down first. Since this is a base of 2 and this is a base of 3, I'm never going to get them to match, so I'm going to switch it over to a log. So log base 2 of 3 is equal to 2x plus 2. Subtract the 2 over, and I'm subtracting this 2 over, and then divide by 2. So x is equal to all of this, but don't forget, log base 2 of 3, you'd have to do log 3 divided by log 2, close that parenthesis, minus 2. Either hit enter before you divide by this other 2, or do extra parentheses around your numerator. When you type it in, you should get that x is about negative 0.208. So some people will struggle with this. You might want to do like log 3 divided by log 2, enter. Minus 2, enter. Divide by 2, enter. Or you'd have to group your this fraction in parentheses, your whole numerator in parentheses, and then divide by 2 if you want to type it all at once. This one, since I'm adding 2 logs, instead of adding, I can change it to multiplication. So log of x times that quantity x plus 3 is equal to 1. Distribute. So I get x squared plus 3x. And make sure you put that in parentheses because you want the log of the whole quantity. And without the parentheses, it's really just saying log of x squared and then plus some random 3x. At this point, if you get stuck, remember that you have a base of 10. So I can rewrite this as 10 to the power of 1 is equal to x squared plus 3x. 10 to the power of 1 is just 10. Since I have more than one type of x, I'm going to get everything on one side, set it equal to 0, and factor it. And I want my leading coefficient, the one that's with the x squared, to be positive. So I'm going to subtract the 10 over. When I go to factor, I don't have to do my cheater step since it's just an x squared, so that's nice. If you need to pencil in a 1 for your rainbow, do it. You multiply the ends of your rainbow. Negative 10 times 1 is negative 10. and then you add for the middle term. Just watch these negatives. Hopefully you're thinking 5 and negative 2. Double check just to be sure. 5 times negative 2 is negative 10. Add, you get a 3. 5 and negative 2. Kind of run out of room, so I'm going to go over here. You'd have x plus 5 equals 0, and x minus 2 equals 0. When you subtract the 5 over, you get a negative 5. That's kind of a red flag anytime you get a negative. And look, log negative 5, that's not going to exist. So that's not in the domain, you can't count it. Here, when I add the 2 over, I get x equals 2. That'd be a positive, that'd be a positive. That one's a keeper. Now this one does have a slight typo. Instead of this x, I actually want you to change it into a 2. And if it's fixed, then you don't have to worry about it, but it should be a 2. So that's going to move and become a power. So it'd be log base 2 of x squared plus log base 2 of x is equal to 0. Hopefully you note that since I am adding these two logs together, instead of adding, I can multiply. So log base 2 of x squared times x is equal to 0. That would give me log base 2 of x cubed. And at this point, I'm going to use my base to rewrite this. So it'd be 2, the base of 2 to the power of 0 is equal to x cubed. Kind of run out of room. Any number to the power of 0, of course, is a 1. And then to get rid of a cubed, you just take the cubed root of both sides. And the cubed root of 1 is just 1. No positive, negative on a cubed root. That's only on the square root or a fourth root, any type of even root. So it's just 1 for this one. And then finally, our last one. Clearly, they don't have the same base, and I'm never going to be able to write them with the same base, so I'm going to change it to a log. So log base 2, don't write these side by side, of 3 to the power of x is equal to the x minus 3. Okay, this looks weird. Some people will freeze here, but hopefully remember that this x can drop to the front because of the property of logs, and this becomes x times log base 2 of 3 is equal to x minus 3. So this whole term is an x, and this is an x. I need to get my x's on the same side, so then I can factor out the x's pretty much. So I am going to subtract this x over. So I'm going to have x log base 2 of 3 minus x is equal to 0. And since these both have an x, I'm basically going to take an x out of this one and take an x out of this one. Here's me taking the x out. Most people wouldn't write that purple step right there. They would just do it in their head. They visualize it. But this is what I'm doing. I'm dividing out the x so that I only have the log base 2 of 3 left. Minus, I'm dividing out the x, so x over x just is a 1. So I did that. I know I did it correctly because if I would distribute, I would end up with that blue equation portion again. And notice that I did that because now I only have this x left. Oh, and look what I did. I made a silly mistake. I forgot that that was a negative 3. So I have these erasable pens. They're fabulous. So when I subtracted my x over, that should be a negative 3. Goodness gracious, that would have ruined the whole problem. So again, subtracted my x over. I still have a negative 3 on this side. But when I got my x's together, I could factor out the x. So now that I have this x by itself, since it's x times this whole quantity, I am just going to divide that whole quantity over. So I'm going to have negative 3 over log base 2 of 3 minus 1. So you would have to type this in as negative 3 over log base 3 divided by log base 2. That would have to go in parentheses, and then your whole denominator would have to go in parentheses. So I'm going to show you on the calculator how to type this in. So it would have to be like this. Negative 3 divided by This set of parentheses is just to close my whole denominator. This next parenthesis is just to do that fraction with the logs. So it would be log 3. That parenthesis is just closing the 1 around the 3, divided by log 2. Oops. Again, that parenthesis is just closing the 1 around the 2. The extra parenthesis is closing off the fraction of the logs. And then you'd have to do minus 1, and then this last parenthesis is closing off the whole denominator. And you get about negative 5.1285. So again, negative 3 divided by this parenthesis is this one here. It's closing off the whole denominator, so it's grouped together. And then you need extra parentheses around your logs. Unfortunately, on my calculator, it also has me do these extra parentheses around the 3 and the 2. So that's a lot of parentheses. So you have to be very careful how you type this stuff in. So if you're not getting this answer, let me know and show me your calculator, and I'll help walk you through it to make sure you can get it. But that is the end of this set of notes.